There was a time when farmers could walk into a dead field, plant something, and walk away. No bags, no trucks, no chemical inputs measured by the gram. They would return months later to soil that had darkened, softened, and come alive again. Not because of anything they had added, because of something that had always been there, waiting to be used. That time was not so long ago, and that plant still exists. It was called many things across many continents. In India, it was woven into rope and ritual. In Africa, it grew along the edges of subsistence farms as quietly as breathing. In the American South, it appeared in government pamphlets during the 1930s, praised in the language of desperation by men watching topsoil blow away in black clouds across the horizon. It was called sun hemp. It was called Crotalaria juncea. It was called, in older languages and older knowledge systems, simply the plant that feeds the earth. It did not need to be owned to work. And that, in the end, is why the modern world let it disappear. This is Ancient Food Files, a channel built not to entertain, but to preserve. What lives here are the things that systems forgot, the knowledge that was inconvenient, the plants and practices that fell outside the edges of profit. If you have found this place, consider staying. Subscribe not for content, but for the record. Someone should remember these things. It may as well be you. Now, open the archive. The story of Crotalaria begins in the Indian subcontinent, in the dry river plains and sun-cracked agricultural belts of what is now Gujarat, Rajasthan, and the Deccan Plateau. It was growing there before anyone thought to plant it deliberately. Farmers noticed it first at the margins, and the disturbed soil along field edges, growing where nothing else would. And they noticed something else. Where it grew, the earth nearby was different, darker, looser, more alive. In Sanskrit agricultural texts reaching back further than most written records, the plant was documented under cultivation as a green manure. The Arthashastra, compiled around 300 BCE, references the use of leguminous crops to restore exhausted fields before the next growing season. Crotalaria was among them. In the oral traditions of dryland farmers in Maharashtra, the plant carried a name that translated loosely to the one that gives back. Not a romantic name, a practical one. Farmers were not given to romance. They were given to survival, and they recognized what kept them alive. The plant itself is striking in a quiet way. It grows fast, almost alarmingly so, reaching heights of 2 to 3 meters within 60 days under adequate rainfall. Its stem is thick and fibrous, almost woody at the base, pale green fading to amber as it matures. Its leaves are long and narrow, arranged in a spiral that catches light efficiently. Its flowers are yellow, small, clustered along upright racemes that sway in the wind with a dry rattling sound. That sound gave it one of its other names, Crotalaria, from the Greek krotalon, meaning rattle. When the seed pods dry, the seeds shake loose inside them like a percussion instrument. Farmers heard it coming before they saw it. But the sound was not what mattered. What mattered was what happened underground. Crotalaria juncea is a legume. That classification places it in a family of plants that evolved over millions of years, a relationship with soil bacteria so precise and so productive that it functions almost like a transaction. The plant's roots form nodules, small swellings, where bacteria of the genus Rhizobium take up residence. These bacteria pull nitrogen from the air, an element that exists in extraordinary abundance in the atmosphere, but is locked in a form that most plants cannot absorb. The bacteria convert it, they fix it, they transform atmospheric nitrogen into ammonium compounds that dissolve into the soil and become available to any plant that roots nearby. Crotalaria does this faster than almost any other legume. Studies conducted in the 20th century, long after the knowledge was already ancient, confirmed what farmers had observed for millennia. A single crop of sun hemp, turned into the soil at peak biomass, can fix between 100 and 200 kilograms of nitrogen per hectare. Equivalent figures for synthetic fertilizer application run to the same numbers. The cost in currency is almost nothing. The cost in infrastructure is nothing. The plant does not require refrigeration, transportation networks, or petroleum derivatives. It requires seed, soil, rain, and time. It also suppresses weeds. Its canopy closes quickly, shading out competition before competing plants can establish root systems. It harbors populations of beneficial insects. Its deep taproot breaks through compacted subsoil, aerating layers that plows cannot reach. When it decomposes, it adds organic matter that improves water retention in sandy soils and drainage in clay. It is not one solution. It is an entire soil system compressed into a single plant. It was, in every measurable sense, too good to be sold. The historical record of Crotallaria's importance is not subtle if you know where to look. During the Bengal famines of the 18th and 19th centuries, when British colonial extraction had stripped agricultural land of its resilience and monoculture rice paddies collapsed under drought and neglect, subsistence farmers in Bihar and Orissa, who had maintained green manure rotations, many using Crotallaria, survived at higher rates than those who had been converted entirely to cash crop cultivation. The evidence exists in district agricultural reports from the 1870s and 1880s, buried in colonial archives in London and Kolkata. Rarely cited, rarely read. In the United States, between 1934 and 1938, the Soil Conservation Service distributed sun hemp seed across the southeastern states as part of its emergency response to the Dust Bowl. Reports from Georgia, Florida, and Alabama documented dramatic improvements in soil organic matter within a single growing season. Farmers who adopted it as a cover crop before cotton planting saw reduced erosion, reduced input costs, and improved yields in subsequent seasons. The documentation was thorough. The adoption was real. And then it stopped. The disappearance of Crotallaria from mainstream agriculture did not happen because it failed. It happened because it succeeded in a way that created no ongoing dependency. The synthetic fertilizer industry, which emerged in commercial scale following the First World War through the industrialization of the Haber-Bosch process, required purchase. It required distribution networks, retail infrastructure, credit systems, recurring demand. A farmer who planted Crotallaria and rotated it through their fields needed none of that. They needed seed, which they could save. They needed knowledge, which they could pass down. By the 1960s, sun hemp had been reclassified in most American agricultural literature as a niche crop, an alternative option, a regional curiosity. The plant did not vanish from the earth. It vanished from institutional memory. The science did not forget it, even if the industry did. Beginning in the 1990s and accelerating through the 2000s, soil ecologists and agronomists began returning to Crotallaria with the language of modern biology. Research documented its effectiveness against root knot nematodes, microscopic soil parasites that devastate vegetable crops, and for which chemical treatment is expensive and environmentally damaging. Crotallaria produces compounds toxic to nematode larvae. It functions as a biological fumigant, as a pesticide, as a fertilizer, simultaneously, without synthesis. Studies from Brazil documented carbon sequestration rates in Crotallaria-amended soils that outperformed conventional tillage systems. Research from agricultural universities in sub-Saharan Africa showed its potential for rehabilitating degraded laterite soils, lands hardened by decades of extractive farming. The confirmations kept arriving, quietly. Ancient knowledge rarely announces its return. The soil beneath modern industrial agriculture is now in measurable decline. Global topsoil loss is occurring at rates that threaten future food production. Fields require more input each season to produce the same yield. The system accelerates its own fragility. Crotalaria does not know this. It does not need to. It has been prepared for soil collapse since before soil collapse was a phrase humans had reason to use. It grows in degraded ground. It improves that ground. It asks for rain and time. The plant is not a solution proposed by researchers. It is a solution that existed before the problem was created. Knowledge does not disappear. It relocates. It lives in seed banks with insufficient funding, in agricultural journals with small readerships, in the memory of an old farmer who still turns sun hemp into the earth the way his grandfather showed him. The land does not forget what it needs. Nitrogen still moves through the same ancient pathways. The rattle of dry crotalaria seed pods still sounds the same as it did in fields that no longer exist. Nature does not require permission to persist. It requires only that someone, somewhere, remembers to plant. This channel exists for that remembering. Subscribe to Ancient Food Files, not for the algorithm, for the archive, because what cannot be owned should not be lost, and because the earth is patient in ways we are only beginning to understand. The knowledge was never buried. We simply stopped looking down.